Ladies and gentlemen, I would like to extend my gratitude to all of you in the audience, especially because I have just been notified we are trending on Twitter by the hashtag ETAutoSmartFactory. Keep tweeting and sharing live highlights. Moving on to our next session, we have a presentation and Q&A on Factory of the Future through Industry 4.0 with Karsten Mueller, Senior VP, Manufacturing and Quality, Bosch India. I would also like to invite Dipanshu Tomar, Senior Correspondent, ETAuto.com, to moderate this session. Over to you, Dipanshu.
Hello and welcome to ETAutoSmartFactory, bringing continuity in crisis. We are joined by Mr. Karsten Mueller, Senior Vice President, Manufacturing and Quality, Bosch India. He would be giving a presentation on Factory of the Future through Industry 4.0 and sharing insights on how the future factories would look like. Over to you, Mr. Mueller.
Hello and welcome to all of you. Yeah, it's difficult to do it on slides. Yeah, it's just a short flavor I can give you about Factory of the Future. I would like to start with some challenges we are facing, at least in the automotive supplier industry as Bosch. We are really in a big transformation, from product side, from conventionals to new technologies on common rail technology, which comes also with high advanced manufacturing technologies. And of course, coming from very old-fashioned machines to new high-precision machinery, also the challenges with regards to quality, process control is going up, and this will change also the way of manufacturing of all. All of us know what happens in COVID. We have this Atma Nirbhar Bharat, I hope I spelled it right, initiative as well. That's why localization and made in India for us also is a big issue. We have these volatilities, and yes, I think also we need to change our way to manufacture in India to stay in these new advanced technology markets. And that's why also I 4.0 and digitization comes into the place. And it's not only being competitive here. I see India must be competitive on a world-class level, worldwide, on a global base. That's why also we at Bosch, we are thinking about how to become in our plants to a level, how to get to a level of benchmark productivity. Hence, this year we have set up a comprehensive manufacturing strategy. And what is the purpose? The purpose you can see on the upper left is we want to make India a global manufacturing hub. Yeah? This comes with a lot of statements. And the journey to get there is about us. That's why we dot is a statement. We as leaders, we have manufacturing leaders, we have to make it happen. We have to do the necessary changes as well. And it comes with performance. I mean, I come to this later maybe in our discussion. Performance level in India compared to rest of world, we need to close some gaps. And of course, here we need to do something different as well. And it's about transformation, because coming from conventional products to new products also, we need to adjust our resources first before we come to performance. We need to transform. And if you look at the set of 12 strategic action fields I have defined, you can find connected industry as one pillar, but it's not standalone, because only connectivity and digitization will not help to make our manufacturing successful. It comes also with a clear thinking about lean manufacturing as a base, and built on that, digitization will help to develop our, let's say, organizations towards a data-driven improvement organization. So, of course, today I want to speak about connected industry. And for this, for each of these action fields, we have also formulated some kind of strategic guidelines. If we talk about connected industry, there are three aspects we need to focus on. At least this is what we define for our strategy here. It's about connectivity, to connect the machines, to capture the data and make them available. For platforms, that's the second. And platforms means global platforms, because we are not independent in India at Bosch. We are a member of international manufacturing networks. So all the data must also be available for making global benchmarks possible in order to improve the lines synchronously all over the globe. And of course, on the platform, we can also bring the database which we need to enable artificial intelligence, to enable self-services on data analytics and so on. And yeah, last but not least, it's about applications. This is where the data are prepared, ready-made for the people who drive the improvements on the shop floor. And here, of course, Also, some of standard applications clearly linked to platform will be defined in our plants to get also a standard set of activities deployed to the plants. I would like to start with this picture because it's really important to understand. You can see improvements are still made by people. People is on the right side, and you can see here that the user groups are completely different. We have the top management, how I look at it, as the responsible for manufacturing and quality on the India level. I'm interested, of course, in having benchmark KPIs everywhere. But also we have our value streams, our shop floor management. They go into daily routines. They have to get the right data set, real-time available. We have manufacturing engineers doing improvements on quality issues, on productivity improvements. And we have some kind of data experts who do, let's say, advanced data analytics, which is also a key. So the use cases are different. The users are different. The knowledge and enablement of these stakeholder groups is also different. So we also have to think what kind of new skill sets are needed to really come to a data-driven improvement organization. But key is the platform, and you can see the PS platform, which is a powertrain solutions platform, which contains of 3 pieces, and 2 pieces are very important. It's the data lake, where we have unstructured data available for, let's say, analytics and data mining. From the data lake also, we put data into the data warehouse, where we can do very fast and very clear analytics based on reporting factories. Of course, these data needs to be fed into coming from data sources. And the data sources are at least machines, but machines are normally connected to manufacturing execution systems. We at Bosch have defined for this a clear standard. We have an in-house MES system, which we deploy as a standard to all plants worldwide, including India, for new machines. Also, we try to retrofit legacy systems on that. But if the machines are too old, also we put some connectivity devices, which we have developed here in India, for rest of the world in powertrain solutions. So we put some sensors, PLCs and boxes to make them ready also for streaming of data into the platform. So platform is something which is key, which must be a standard to make the data available for improvement processes. But what we should not do is doing the failure of only talking about technology. Technology is one aspect. If we really want to change to a data-driven improvement organization, which is very much needed to come with a top performance, also leadership must change. It starts with me, with my colleagues, deploying this kind and defining these kinds of strategy. We must drive it from the top. We must have a clear strategy of data insight. It's not about having data. We are data rich, but sometimes data insight poor. So we need really to build also some kind of data trust culture, and it comes with quality of data as well. So we need to think much more in which format and which data model we need to deploy in our PLCs in order to make to become a data-driven improvement organization. So this comes with some clear leadership guidance here. And it's about the people I already mentioned. On the right side, the users are still decisive also in the next 5 to 10 years. Not everything will be decided by artificial intelligence, but we need to prepare the data and the information much better so that the people much faster can act on the needed improvements and exactly know at any time where to act. And here also we need people, of course, who are very close to data, who are really hungry to work with data, to work differently like we did in the past. And for this also, because we cannot change every single head in our factories, we need to do some upskilling. We have defined here some digital fluency programs to come to this. And we need also to work differently. It's about also applying Scrum in manufacturing as a leadership framework as well. Because if you have data on a, let's say, a daily base, also you need to change your style of working. So many things must happen on the people side, while we are spending a lot of time talking about technology only. Now, what is the technology behind? Technology is the enabler, but you must also change the way how the organization is working. So it's a full set of changes. And if you have seen in my strategy, the we aspect, passion is one field, strategic action fields. In this passion, we have also placed what kind of competency and what kind of change is needed to change the people and the way they work. But of course, I want to give you a flavor what we are striving at and what are the things we are changing. I mean, starting with shop floor management. So of course, shop floor management is key. Being successful on the shop floor, close to the data, react fast is key. And we have a quite good setup of KPIs and shop floor management cycle at Bosch, which is established throughout the world in the same fashion. But it's still paper-based, it's manual, it's good to have it. But you can see already in our plants, in most of our plants, we switched over to the middle. It's simply changing from paper to paperless, to be real time, to prepare standard data sets automatically, generated automatically, and discuss on the shop floor only digital. So you can see here Active Cockpit, which is also a product sold by Bosch. You can buy it also as an external company. But this is what we are using to do the shop floor management, and all the data will be available. So a lot of time, we made an analysis, so you can save a lot of, let's say, a focus on indirect personnel who were preparing paper in the past by just using automated data, and focus more on improvement work. And on the top you can see, and we are already in this, that we are able, because we have this data, we have these active cockpits on our lines, we can do also worldwide comparisons all over our international manufacturing network, can compare lines even down to a level of single stations, can do benchmarks, and make sure by doing this, that all the lines are running on the same performance level, which is also a good, let's say, a good tool to distribute improvement work all over the world, while everybody is participating and benefiting out of the solutions. A big field is visual inspection. Visual inspection, you can see specifically also in our plants here in India. And normally you have these manual processes going into microscopes or paper-based guidelines. Recently, we have these, let's say, semi-automated visual inspections where the machine makes proposals to the operator and saying, I propose this one is a good one, and operator must confirm, because this is very advanced visual inspections. So we have this kind of a small artificial intelligence already implemented in our manufacturing. But we already go one step beyond. So we have fully automated deep learning based visual inspections. Just to give you an impression, worldwide, only in Powertrain Solutions, we have 1,600 visual inspection workplaces, which are operated in 3 shifts. So here also automating it and bringing it to a higher level of automation comes also with quality. As you might know, that AI algorithms as of today are much more reliable than manual inspections. So this kind of evolution will take place. Same in logistics, as we have manufacturing execution systems, also we have logistics execution systems implemented. So very much we are already in the middle of the picture. So these case by case forklift transportations is over. We have digital supported milk runs running highly flexible, getting clear, let's say, hints where to go and where to pick and where to bring the parts. But already we developed in-house also autonomous shuttles, which are based on LiDAR systems, finding their way on their own based on swarm intelligence and let's say in-house GPS, bringing only small, let's say one batch. This also is something of evolution which we can see. By when we can see this in India, I don't know. Of course, everything is based on economics, but the first step, for sure, we will see very soon, and we have already implemented in some of our key plants here as well. Same comes with robotics. Of course, still our lines here in India are very much manual driven. And here it's all about bringing excellence into these manual driven lines. And also here a long way to go, having the right lean line designs, one-piece flow thinking, high level of standardized work where we are by far not benchmark. But going more and more into advanced manufacturing, like many countries have done this journey already. Just thinking about China, industrial robots are next step. But of course, looking into manual lines, collaborative robots are the robots of choice. And we are already implementing collaborative robots here in India in some of our lines in order to try how we can drive hybrid manufacturings in our manufacturing surrounding. And this is one thing I feel in the next years will come more and more, that people and machines work together really hand in hand. Maintenance for me also, let's say, a passion and something which is really important. Very much, let's say, manual driven. In the past, in the most cases, we simply have an ERP system like SAP or something like that, where we do all the ordering. But in the middle, this is element of our manufacturing execution system already. We have a maintenance support system, which supports and guides digitally all our maintenance guys through their journey. So they're just going out with a laptop. They have the problem solvings, everything on hand. They can order directly spare parts from the machine without going back to the storage. So it's a full comprehensive, let's say, system where they can open and close orders, maintenance orders on site without going back and forth to the maintenance center, and this saves time. And here also it's all about efficiency. And the next step, specifically in our new machines built mainly in-house in our machinery departments, it comes to predictive and augmented reality. So all these new machines we have in 3D drawings already, and also the PLC and the programming is incorporated in this. And hence we are able today, if we face some line stoppages with augmented reality, even let's say untrained operators will be able to identify the point of the problem, and will enable people of today to do much more, let's say, autonomous maintenance, which is currently done by specialists. So this is a big benefit which will come in the next years, making unskilled people, giving them the impression that they are much more skilled just by using human machine interface and good guide. And of course, I talked about platform thinking. I mean, very much and very often, specifically in quality problems when we are facing, we work on huge Excel-based reports trying to find out some kind of data. This is time consuming. We have to copy from left to right because we don't have centralized databases. This we will change with our platform approach so that all data is available at one place with regards to one product and worldwide manufacturing, so that we can do all these analytics much faster. And also we can implement then, based on real-time data, some rules. We have some rule machines developed with our Bosch Innovation Cluster Artificial Intelligence, which we have here at Bosch in-house, so that based on this data also we can make some kind of decision. We can make some trend analysis and give some hints to the people. And if you look into the third step, where we really use artificial intelligence for self-regulating processes, which we have stepwise in some of the very advanced machines. This will be the future, that based on some trends analytics, and based on non-written rules, the machine itself gives some hints that something is going wrong, and gives this kind of hint to the people that we can act accordingly. And last but not least, building up new machines is also important. How do we invest in future? Of course, what is standard at Bosch is that we do physical mock-ups of new lines. It's mainly cardboard manufacturing, so that people can try on a cardboard mock-up the new line, doing by, let's say, learning by doing, optimization cardboard before we build the machines in. But recently we went over to these material flow simulations, bottleneck detections, as you can see here. So this is the base for the new planning. So every new machine should be mirrored in this digital model in order to find out in a very early stage. We will face problems with regards to material flow, buffering, and so on, to start very fast on a very high level of OEE in the ramp-up phase already. And of course, the last step is, and these are first trials we are doing, that all the machines are in the 3D model, as I already mentioned in the maintenance part. I mentioned programming of the PLCs already in a digital base. So when the machine is there in steel and iron, we can just copy the software and the machine will run very fast, so we can reduce the lead time of machine build also by 20 to 30%, investment also by 10 to 15% by doing so. So this is a prerequisite now for us, how we plan and do in investments. All in a short, you can see what's important to me. Data-driven improvement organization is a target condition we must arrive at. It comes with connectivity, it comes with platform thinking and analytics, because this enables all the examples I've shown to you. Artificial intelligence driven is only possible if you have a clear picture where to store the data, how to store the data, and how to build the algorithm based on that, and then make use of it in the supply chains. So this was my input. I wanted to give you in a short, it was a short journey. Over to you if you have some questions. I'm happy to answer them.
Thank you so much, Mr. Mueller, for giving such a detailed and insightful presentation. So I would like to understand more about connected manufacturing. Why is it important in today's time, and what manufacturers can really achieve by implementing this technology?
I mean, I give you a simple example. We are transforming now from internal combustion engine to electrification. Electrification is more, let's say, a commodity. If you want to survive in this kind of market, you must perform with your whole manufacturing at the top benchmark level of performance. Where does, for example, benchmark performance begin? If you have OEEs on your lines lower than 90%, yeah, you're far away from benchmark. So we must really readjust. And I learned this during my stay in Japan, really hardly. Between 90-95% you must be. The question is, can you arrive on this high level of OEEs without having this clarity on details? And my answer is maybe, but if you have I 4.0, you get this transparency, very detailed, you get all the data you need to really identify the things need to be done to arrive at this, let's say, benchmark performance level. So for me, it's no option to miss that out. If you want to stay in the market successful, we need to do it this way to really come to this benchmark performance level. And it's not only about efficiency, it's only also about zero defects. And for zero defects also, you must make a change, yeah? From problem solving to problem preventing company. And only data analytics will enable you that you can realize when processes start to show abnormalities. I'm not talking about deviations, abnormalities, so that you can react before failures even are happening. That's why you need it.
When we say disruption on the shop floor, what are the most likely changes that will happen soon in the next 2 to 3 years?
I've given you some examples already in my presentation. I think, I mean, it starts now in the way how we lead, yeah, based on data, real-time data. So of course, if transparency is there, the people can act much faster, react much faster. So you will see for sure the whole shop floor management, the deviation management will be based on visuals, will be based on real-time data, and the people much more will depend on this data and work with this data. So this is something which is different. Maybe you will see also variables which give you hints for the frontline managers in the lines with some notifications if processes start to deviating, so that you get notified, you can act directly and immediately can look and fix the problem before it becomes a problem. So I think the digitization and the interaction between data and people will be there, much more there than of today. Maybe today it's on a daily basis, but you will touch and feel it, let's say, real time in future, so that you have every second of the day, you have the feeling, what is the condition of your manufacturing and what is next, what you need to do in order to keep your manufacturing running on top performance level.
Do you think our workforce are ready for this change?
It's yes and no. I mean, if you look at the blue-collar people, I think there are good chances if you do it right with human-machine interfaces. There's a good chance that specifically the blue-collar people can be much more involved in the manufacturing processes. As of today, they are only manufacturing, you know, assembling, they're doing the work, if the machine stands, maybe frontline managers, experts are coming, but with a good guidance and human-machine interfaces, maybe they can even extend, you know, their work and will be enabled to also do some kind of autonomous maintenance if we skill them right. On the other hand, working based on data, we need to develop some kind of skills in data analytics, even in advanced analytics. I think the job role of manufacturing engineers, yeah, will change a little. They need to also become some kind of experts in doing data mining, which will be the base, the future base for the improvement work. So this kind of skills we need to do. And this is something where we need to do something. So we are not ready, but I don't see it as a big disruption. I see it more like a very fast evolution. So we can handle this because everything also comes with some kind of upgrading and investments. So it's a journey we need to start. We need to step in fast, but it's something which we can handle.
In terms of manufacturing, what advantages India offers and where are the gaps which really need immediate attention?
I cannot tell for India in general. I'm here in India now for since the beginning of the year. And unfortunately, due to lockdown, I could not travel so much and have a look in many plants outside Bosch. But I can tell you, as I was responsible worldwide for manufacturing and powertrain solutions, what we need to do is really to close the gap with regards to digitization. So we are lagging behind in India. This is also one of my main motivations to bring this connected industry thinking into the leadership heads. I think the first thing we are doing is discussing how much does it cost. We don't think coming from the end, what will it lead to in 3 to 5 years if you don't do it. And if we don't do it, we will never arrive at world-class level. And this kind of thinking we need to implement coming from the end and not from the beginning. If we don't think benchmark, yeah, I mean, this kind of gap we will not be able to close. So there is a need for action. We have the right people here. I mean, the smartest people, for example, MES systems, the IT systems at Bosch, 50% of the software is done here in India. So we have the right people to do it. Now we must start implementing it also in our factories to close this gap also.
One last question. Defines factory of the future in your words.
I mean, at the end, it's all about, let's say, being competitive, staying competitive. For me, I mean, it starts all, I'm enthusiastic on Bosch production system. So what does smart mean? Smart for me means we need a clear understanding of lean manufacturing, how lean manufacturing works. It's all about tact, flow, and rhythm. My people know this, what I mean with this, how manufacturing should be. And based on that, yeah, we must put the data-driven improvement organizational thinking in a very lean thinking, so that everything in these lean plants is connected, so that we create speed at any stage of manufacturing, can react very fast. And in the lines, as I mentioned, people and machines will interact much more smoothly, hand to hand. So we will see a lot of, let's say, cobots interacting with people, and this will improve. This will improve. And at the end, it's all about that we can produce tomorrow better than today, and tomorrow will be not without data and connected.
Thank you so much, Mr. Mueller, for joining in today.
Thank you, Mr. Mueller, for sharing those key points.